This example shows us how to compute the consolidation settlement of group piles. A group pile consists of 3 rows of piles and 4 columns of piles distributed in distance. The distance between pile and pile from center to center equal to 2.5 times d. d is the diameter of the pile. The diameter of the pile equal to 0.4 and the length of the pile equal to 18 meter. Determine the consolidation settlement of the piles. All clays are normally consolidated. Given Q group equal to 2200 and 200 kilonewton. The applied load on the group of the piles equal to 2200. The soil profile is assumed to be as in the following table. Layer 1, the elevation is +1 to -1. -1 below the ground level. The ground level of the soil takes elevation equal to 0. The type of the soil is sand. The thickness of this layer is 2 meter. Engineering characteristics of the soil: gamma equal to 16, the unit weight of the soil, 16 kilonewton per meter cubic. The second layer has elevation from -1 to -14. The type of the soil, clay soil, and the unit weight equal to 18 kilonewton per meter cubic. The original void ratio equal to 0.8 and coefficient of compressibility equal to 0.28. The thickness of this layer will be 13 meter. The third layer is from -14 to -26. The type of this layer is a clay and the unit weight equal to 18.5 kilonewton per meter cubic. The original void ratio equal to 0.7 and coefficient of compressibility equal to 0.2. The thickness of this layer is equal to 12 meter. You can get it also by subtract -26 -14 gives us, or -14 -26 gives us 12 meter. The rock layer is at a depth equal to -30 or at a level equal to -30. To compute the consolidation settlement, we have to follow 3 steps. The first step is to make a sketch for the problem. In this sketch, draw the soil profile and the pile group, indicating the thickness of every layer. The second step is to locate the raft, equivalent raft, which is equal to 2/3 times the length of piles, and also indicate the thicknesses of all clay layers under the equivalent raft. The third step is to apply the consolidation settlement and compute the consolidation settlement of every layer by using Terzaghi equation. Now the solution is draw the pile group and locate the equivalent raft and calculate the consolidation settlement. Let us start with the first step. Because the length of the piles equal to 18 meter. The length of the pile equal to 18 meter. So 2/3 length of pile 18 meter gives us 2/3 by 18 equal to 12 meter. The depth of the equivalent raft equal to 12 meter. Let us now show you the sketch of the problem. There are 3 rows of piles and 4 rows or columns of piles. 4 columns of piles. To calculate the length of the group, 3 times the spaces between piles. Since the number of spaces are 3, 1, 2, 3, and 4 piles. 4 minus 1 equal to 3. Now 3 times the 3 times the 2.5, because every space is 2.5 d diameter of pile, plus 0.2 half pile, 0.2 from this side and 0.2 meter from this side. The length of pile equal to 3.4 meter and the width of the pile equal to 2.4 meter. Always the width of the pile is the shortest dimension. Now this figure shows us the soil profile and the pile group. In this view there are 4 piles and the layers. The first layer is sand layer, 1 meter above the ground level, 1 meter above ground level, and 1 meter below the ground level. The length of pile equal to 18. The first layer, the thickness H1 equal to 2 meter and H2 equal to 12 meter and H3 equal to 4 meter. First is to locate the equivalent length. The equivalent length, the equivalent raft here is located at a depth equal to 2/3 times L. L is the length of pile, which is equal to 12 meter. 12 meter, the depth of the equivalent raft, 12 meter. This layer is a clay layer, but we will consider the clay layer under the raft, the equivalent raft. Therefore, the clay that will be included in the computation of computing the consolidation settlement will begin from the level of the equivalent raft. The first layer will be 2 meter, and this is the second layer in different color, and this is the third layer. For the first layer, we have to compute the overburden pressure at the middle of the layer. The overburden pressure at the middle. This is the middle of the layer, and we have to calculate the overburden pressure for the layers, in all that passes in all this distance. And the overburden pressure will start from not from the base of the cap or above of the cap, top of the cap. It starts from the ground level, and the ground level here is 1 meter above the cap. To compute overburden pressure, we begin from this point to the middle of the first layer, and then for the second layer, this is the middle of the second layer, and also we have to compute the overburden pressure at this level. Then the overburden pressure also at this level. All the clay layers under the equivalent raft will be included in the computing consolidation settlement. Also, the stress increase at the middle of the layer here, and at the middle of the second layer, at the middle of the third layer, will be computed based on the method of 2b over h. 2b over h. This method, 2-1, will be used to compute the stress increase at any level. we will compute the stress increase at the middle of the first layer, the middle of the second layer, and the middle of the third layer. Here is the calculation. For layer 1, delta sigma stress increase at the first layer equal to applied load 2200 kN over length of the group plus Z1. Z1 is from the equivalent raft to the middle of the layer. Since the thickness of the layer 2 meter and it directly located under the equivalent raft, the distance from the equivalent raft to the middle of the layer will be 1 meter. Therefore, Z1 will be 1 meter. Here, 1 meter. And the width of the group plus Z1 also 1 meter. Hence, delta sigma equal to 147 kilonewton per meter cube. The overburden pressure will be calculated by the following procedure. The first layer 1 meter multiplied by 16, add 1 meter by 16, 2 meter by 16, since the water level at the base or at the bottom of this layer 2 meter or 1 meter by 16 plus now the overburden pressure along the pile to the middle of the layer. 1 times 16 plus 1 meter times 16 plus the distance from the bottom of the pile cap to the level of the equivalent raft equal to 12 meter. 1 meter is included in the computing the overburden pressure of the sun. Remains just 11 meter. So 11 meter multiplied by gamma saturated 18 minus 10 or 9.81 plus the distance here 1 meter multiplied also by 18 minus 18 minus 10 9.81. 1 multiplied by 16 plus 1 multiplied by 16 plus 11 multiplied by 18 minus 9.81. This is along the pile plus 1, this is along the thickness of the layer. 18 minus 9.81 leads to the following results: 130 kN per meter square. Delta the settlement will be computed by the following equation: 0.28 the coefficient of compressibility multiplied by the thickness of the layer equal to 2 over 1 plus E naught the original void ratio multiplied by log sigma naught dash the overburden pressure plus stress increase over divided by 130 the sigma naught dash gives us 0.1021 meter. This is the settlement of the first layer. To compute the settlement for the second layer, this is the second layer, from the base of the first layer to the top of the third layer. In this layer we have to compute sigma naught at the middle of this layer, and also delta sigma stress increase at the middle of the layer. To compute the stress increase at the middle of the layer, we have to use Z from this level, the level of the equivalent raft, here 2 meter, here 2 meter, and from the bottom of the first layer to the middle of the second layer, this is 6 meter. 6 plus 2 would be 8 meter. From the equivalent raft to the middle of the second layer, Z equal to 8 meter. Now replace 8 meter in this equation. 3.4 plus 8 meter. 2.4 plus 8 meter. Therefore, delta sigma or delta sigma 2 equal to 18.55 kilonewton per meter square. The overburden pressure at the middle of the second layer will be 1 multiplied by 16 plus 1 multiplied by 16 plus 11 multiplied by 18 minus 9.81 along the pile from the base of the first layer to the equivalent raft, plus 2 multiplied by 18 minus 9.1. This is the first layer plus the second layer to the middle of the second layer multiplied by 6. Sigma naught dash equal to 182. Now replace delta sigma and sigma naught in the consolidation equation. The coefficient of compressibility for the second layer equal to 0.2 multiplied by the thickness of the second layer equal to 12 meter plus 1 divided by 1 plus 0.7 the original void ratio, log sigma naught dash plus delta sigma over sigma naught dash. Sigma naught dash increased with depth, and the stress increase decreases with the depth. For the third layer, also we have to compute the overburden pressure. The overburden pressure can be computed by basing on the previous value of sigma naught dash 182 plus 6 the half of the layer plus half of the third layer. We have to compute sigma naught dash at the level or at the middle of the third layer, from the level of the equivalent raft to the middle of the third layer. We can compute the overburden pressure start from this point, from this level to the middle of the third layer, or continue, for example, continue from the second layer, the level of the second layer, to the middle of the third layer. With respect to delta sigma computed based on this distance from the level of the equivalent raft to the middle of the third layer. Now for the third layer, delta sigma 3 equal to 2200 divided by 3.4 plus 16 meter. 16 meter is the distance from here 2 meter plus 12 equal to 14 plus 2 meter equal to 16 meter. Now use the equation for the consolidation equation to compute the consolidation settlement for the third layer. 0.25 is the coefficient of compressibility, multiplied by 4 is the thickness of the third layer, divided by 1 plus 0.75. 0.75 is the original void ratio, log sigma naught dash plus delta sigma. Look to the value of the delta sigma. It decreases from 18 to 6.16, divided by the overburden pressure gives us just 0.006 meter. Now use the total, the equation of total settlement. The total consolidation settlement, or the consolidation settlement of the group of the pile, equal to the consolidation settlement for the first layer, for the second layer, for the third layer, gives us 0.167 meter or 167 millimeter.